Ansel, somebody, Ansel's microphone is on. Kindly mute yourself. Otherwise, I will remove you from your team. Okay, last class what I have taught?
Rabbit's test.
Rabbit's test.
Till now, how many tests have been covered?
2.
4 tests.
4 or 3?
3, ma'am.
That's three.
Comparison, rabbit test,
Three.
Comparison ratio and rabbit.
Okay, now you are having Cossi root test. The thing is, if un is a positive term series, so you will have limit n tending to infinity, un whole to the power 1 by n is equal to L. If you get a limiting value, which is some number, which is L, then summation of un converges if L is less than 1. Diverge if L is less than 1. So test will fail when it is equal to 1. So one benefit of this is that if you have any expression which is in the power of n, okay, like you are having a term of this form n by 2n plus 1 whole to the power n. So if you apply over here the comparison test, then it is difficult because see, when you apply the comparison test, what you are getting? Are you able to get any value which is in the form of power series?
No, ma'am.
Yes. And if you apply the ratio test, can you use it?
No, ma'am.
Because over here the power becomes n plus 1. Again, n plus 1 by n. Okay. You simplify the term, then you will be able to understand because some expression it can be done. So you are having n plus 1 by 2n plus 3 power n plus 1. It cannot be done because see when n is increasing, then this is also increasing. So this is varying. So you cannot cancel the term. Isn't it? If you take the division. Like if you take the division of this by this, so it is difficult to cancel. If it is able to cancel, then you can use the ratio test. So in this case, the best option is that you apply the Cossi root test.
And what is the name of the test?
Yeah, Cossi root test. CAUCHY''S. It was developed by the scientist.
It is NOT or it is NUT?
It is root.
Root.
Thank you, ma'am.
Root test. Okay, now let us take one example. Test the convergence of this series. So whenever you see any power term, then directly you can come to this series instead of wasting time. Okay, for other tests. And so on. So you find the nth term. What will be the nth term of this series? Again, somebody's mic is on. If I find anyone's mic on, I will just remove you from the team. If you're not interested in attending the class, you please don't attend the class. It is difficult to teach.
Ma'am, is it n square by n plus 1 power n?
Ma'am, it is n plus 1 to the power n plus 1 upon n square minus n plus 1 upon n.
N plus 1.
To the power n plus 1.
You take the term in order. See, over here you are having the first term, which is the group of numerator and denominator terms. So when it is one term extra is there. So it becomes n plus
Convergence series.
n plus 1 by n,
n.
the whole power n plus 1,
I'm convergent.
whole power n plus 1,
Wait, let me just generate
minus n plus 1 by n,
Whole to power minus n.
whole to the power minus n. Minus n. कोई क्लास ज्वाइन नहीं कर पा रहा है क्या? या हेलो हाँ हेलो अच्छा वो अभी क्लास चल रही है मैडम, बाद में बात करते हैं. हम सोचे कोई स्टूडेंट ज्वाइन नहीं कर पा रहा होगा इसीलिए. ठीक है, अभी क्लास बाद. अच्छा. So finally what you are getting? The value when you take limit n tending to infinity?
1 upon e minus 1.
Yes, 1 upon e minus 1. Now what will be the value? What is the range of e? Physics you have studied, exponential function range. Means the maths also you have studied. What is the range of e? It lies between
2 and 3.
Minus infinity. 2 point.
Lies between 2 and 3.
So what will be the value of this term?
0.5 to 0.6.
So will it be less than 1 or it will be greater than 1?
Less than
1.
Convergence series.
It is convergence series. Got it? So let me see the answer first. How you have done. Somebody post it.
Ma'am, is there any proof for this test?
No, proof is there, but it is not required for you. It is a big proof. Looking at the proof, students will collapse.
Okay.
Post soon so that I can move to the next part. Anyone can post who have done. For others, you do another problem. You do another problem. Test the convergence of this series. And so on. Looking at this also, you can directly see that you can apply the Cossi root test. If there is no power term, then you should go for root ratio test, because comparison test will not be applied here. मेरा वाला स्टेपलर वर्क नहीं कर रहा है ना।
For x greater than equal to 1, it is divergent, and for x less than 1, it is convergent.
Yes, ma'am.
And
For less than 1, it is convergent. For greater than equal to 1, it is divergent.
you are missing one point. For x equal to 1,
Pardon me, please repeat.
what will be the situation when x is equal to 1?
It will be divergent. Diverging. Cossi test fail. Cossi test fail कर जाएगा यहाँ पे. तो
फिर कैसे प्रूफ कर रहे हो? जब वो फेल किया तो कैसे प्रूफ करके बताया कि वो डाइवर्ज कर रहा है? कौन सा टेस्ट लगाया?
मैम मैंने लिमिट n टेंडिंग टू इन्फिनिटी un कर दिया है. इसमें एक टेस्ट था कि अगर इक्वल टू 0 होगा तो डाइवर्जेंट कन्वर्जेंट कुछ भी हो सकता है, लेकिन अगर इक्वल टू 0 नहीं है तो फिर डेफिनेटली वो डाइवर्जेंट होगा. तो मैंने वो टेस्ट.
कौन सा वाला टेस्ट लगाया? इक्वल टू 0 वाला टेस्ट तो हम नहीं बताया.
मैम at x equal to 1 it is convergent.
हम इक्वल टू 0 वाला तो नहीं बताया अभी.
बुक है ना.
हाँ तो कौन सा वाला थ्योरम लगाया? बुक है तो कौन सा?
Ma'am at x is equal to 0 we put x equal to 1 we put it in the un term and it becomes n plus 1 upon n plus 2, and when we take limit n tends to infinity of this we get 1 by 2, so it is convergent.
We get 1 not 1 by 2.
Yes, sorry,
It's coming 1 by 2.
It's what?
ठीक है.
Ma'am, can you just tell the final answer? Ma'am, it's get a copy.
Final answer: converge when x is less than 1, diverge when x is greater than 1.
Yes, ma'am.
Now x is equal to 1. बाकी बताओ.
इक्वल टू 1 पे डाइवर्जेंट.
जब x इक्वल टू 1 हो रहा है तो हमारा सीरीज क्या बन रहा है?
डाइवर्जेंट.
Convergent.
ऐसे कन्वर्जेंट डाइवर्जेंट नहीं होगा. दोनों चीज पॉसिबल नहीं है. एक होगा.
डाइवर्जेंट होगा मैम.
बताओ कैसे हो रहा है?
मैम आपको पिक भेज दे रहा हूँ उतने की. मेरे को थ्योरम का नाम नहीं याद है.
तो थ्योरम का नाम जरूरी है याद करना. डिस्क्रिप्टिव होगा तो बिना थ्योरम के नाम का सॉल्यूशन आने से भी नंबर नहीं मिलेगा.
एग्जाम में थ्योरम का नाम लिखना पड़ेगा.
हाँ. कैसे पता चलेगा क्या यूज किए हो? अगर डिस्क्रिप्टिव आता है तो, अगर एमसीक्यू आता है तो फिर वो नहीं. अब ये भी हो सकता है कि कोई थ्योरम बता दिया, बताएगा कि इसका नाम बताओ क्या है.
हम शायद इसका नाम नहीं है, बस स्टेटमेंट लिखा था बुक में.
कौन सा थ्योरम बता रहे हो? 0 वाला भेजो तो फोटो खींच के.
भेज रहे हैं.
सिलेबस में है उसी को फॉलो करो. सिलेबस में अलग अलग रूट टेस्ट बताया ना. देखो कौन सा टेस्ट की हम भी सीखे.
Ma'am, will you show the nth term of this series, please? Ma'am,
Yes.
I think it should be n plus 1 upon n plus 2 into x to the power n.
Yes, ma'am. X to the
Because
power
1 by 2 is 0 term of this series, na?
Ma'am, x to the power n minus 1. N by n plus 1 whole to the power n minus 1 into x to the power n minus 1.
Yes, sir. It will be n minus 1.
इसको n minus 1 कर दो.
And same goes for u n by n plus 1 to the power n minus 1.
क्या n minus 1 किसका?
मैम फर्स्ट टर्म का भी n minus 1 आएगा, क्या कि हम लोग 0 से स्टार्ट कर रहे हैं.
To the power n is not satisfying the second term.
Ma'am, can we write?
Powers are n minus 1.
This term is not satisfying second term. This.
It should be then.
अच्छा यहाँ पे
Can't we neglect the first term?
यहाँ पे then if you neglect
Now we can neglect the first term 1 by 2 and then start from the second term 2 by 3.
ठीक है, हमने थ्योरी बताए थे यू कैन टेस्ट द कन्वर्जेंस और डाइवर्जेंस इफ यू नेग्लेक्ट अ स्मॉल पोर्शन ऑफ द टर्म. मतलब अगर ये इन्फिनिटी में जा रहा है तो इन्फिनिटी में अगर कोई नंबर भी ऐड करेंगे तो इन्फिनिटी में ही जाएगा ना. तो अगर ये छोटा नंबर हम ऐड कर रहे हैं तो इन्फिनिटी में जाएगा. अगर ये कन्वर्ज कर रहा है, अगर हम उसमें कोई नंबर ऐड करेंगे तो वो भी एक फाइनाइट वैल्यू हो रहा है. ठीक है, तो इसको हम अगर ऑमिट कर देते हैं और यहाँ से शुरू करते हैं तब ये पैटर्न बदल जाएगा. तो ये हो जाएगा हमारा n+2.
मैम अगर फर्स्ट टर्म को हम एज ए जीरो टर्म 1/2 को ट्रीट कर रहे हैं तो n+1 अपॉन n+2 इंटू x टू द पावर n वैलिड होगा एन टर्म.
हाँ, थ्योरी सबसे पहले हम जब शुरू किए तब हम बताए थे there will be no effect in the convergence and divergence of the series if we add or remove a portion.
Yes ma'am, ultimately we get limit as 1.
क्योंकि वो इससे भी देखो ना, अगर थ्योरम नहीं भी है तो यहाँ से जज कर सकते हो ना. जैसे हम बता रहे हैं इन्फिनिटी में बहुत लार्ज एक नंबर है, लार्ज नंबर में बताया छोटा सा नंबर एक ऐड करो तो वो भी तो लार्ज ही बताएगा ना.
Yes ma'am.
तो ये हो गया. So now let us take another test. और वो टेस्ट जो कौन बता रहा था कि कौन सा बुक में तो उसको पोस्ट करना, हम देखते हैं कौन सा टेस्ट है.
Ma'am, what to do for x equals to 1?
The test is failing. Obviously, you cannot apply any other test. When it is in power of n, तो यहाँ पे क्या है? You are getting n plus 1 by n+2. वोल्ट ऐसे ही आ रहा था ना?
Yes ma'am.
Yes ma'am.
Yes ma'am.
Into x की power.
Into x power n.
x1 है.
हाँ, x1 हो गया ना? So x is removed. So अब you cannot apply the comparison test.
मैम बट इसमें कंसेक्यूटिव टर्म्स का साइज तो कम होता जा रहा है ना. मतलब जैसे इन्फिनिटी की तरफ मूव करेंगे नंबर ऑफ टर्म्स, जब n इन्फिनिटी की तरफ जाएगा तो साइज ऑफ टर्म छोटा हो रहा है ना, तो हाफ इग्नोर कैसे कर सकते हैं?
तो ये भी तो हम बताए थे 1 by n. ये कन्वर्ज करेगा ना डाइवर्ज करेगा. एक थ्योरी बताए थे ना, if the limiting value is 0 does not guarantee that it will converge.
अच्छा.
वो है कंफ्यूजन है, ये चैप्टर सीरीज और सीक्वेंस थोड़ा कंफ्यूजन है. ठीक है, नाउ लेट अस कम टू कॉसी इंटीग्रल टेस्ट. कोई एक बता रहा था स्टूडेंट, somebody was saying about the Cossi integral test, how when we convert the series.
Ma'am, before you wrote one series, ma'am, n+1 by n+2 whole power n. Ma'am, if we take the limit of that, we are getting 1 by e, right?
Yes, 1 plus 1 by n whole to the power n is e. Yeah, you are right. You are right. So what
converging we can't say because e 2.7. Okay.
So can you say about the convergence? 1 plus 1 by n whole to the power n is 0 when we take the limit. Can you say about the convergence? Anyone? इसको सोचना, नेक्स्ट क्लास में हम बताएंगे. अब आना now Cossi integral test. In the first class, one student was saying that we can convert the series into an integral and then we can evaluate the integral. So same thing is over here. So if you have a series of positive terms, okay, and if you see that the nth term of the series can be expressed as some function form, and the series value is starting, if suppose it is in the form of summation n equal to 1 to infinity, and the value of this function is decreasing as n is increasing, then we can convert this into an integral, and this integral will not be a definite integral, it will be an indefinite integral because the limit over here is infinity. So this will be converted into an integral. If it is starting from 1, so this will be 1, and if it is starting from 2, then the integral value will be 2. Okay, so this will be this function into dx. So when we say that if the limiting value of this integral is finite, then the series form will be convergent un, because we are getting this fn from the series itself. Okay, so when the integral value of this indefinite integral is finite, then we will say that un is convergent. If it is infinite, what do you mean by infinite?
Divergent.
So this is also very simple to test. If you have an expression and you can solve it, it is simplest way. The most simplest is comparison test and Cossi integral test. And ratio
Ma'am,
test.
please explain it once again, please.
Yes, ma'am. Yes, ma'am.
Okay, I am saying that if you have a series which you can write it in some, when you write it in a summation form and you see that the nth term of the series is decreasing, okay, with the increase in value of n, then you can convert this series, infinite series, into an indefinite integral, which is in the form 1 to infinity, because when n is starting from 1, you have to make a note of, yes, it is not always 1 that you will be given a series. Okay, so if it is from 2, then you have to change the limit value. So the starting as well as ending value, that will become the upper and lower bound of the integral. So you're having 1 to infinity, this function becomes fx dx. You can also write fn dn also, that is not an issue. So if you get a definite value of this, then we say that the series is convergent. If you get an indefinite value, the series is divergent. So proof of this is not required. You just use the application of this. Now let us take the example. Test the convergence. Test the convergence of this series. So you start from the first concept by comparison test whenever you get a series. So comparison test you cannot apply because T series you are getting some form, but it is difficult. Then you go root test. You cannot apply because this is log term. If you apply, then you have to break the expansion of logarithmic term. Okay. So root and Rabi's test, these are connected. And you cannot apply the Cossi also because there is no power of n. So you can easily apply them because this function you can see, this function is decreasing, isn't it? So you can convert this into a series into an integral and then evaluate the integral. You know how to evaluate the definite integral, indefinite integral? Definite you have studied. Have you studied indefinite integral? How do you evaluate?
Yes, ma'am.
You have studied teachers. Higher secondary level you have studied?
Yes.
Yes, ma'am.
Okay, you try it yourself, then I will see if you are not able to do. Do the integral, evaluate the integral, post it, and then I will see.
Ma'am, it is divergent.
Yes, ma'am, it is divergent.
It is divergent. Just post the solution so that I can see how you have taken the limit and how you have done.
Ma'am, it's x ln x minus x coming up after integration.
It is coming up to?
X ln x minus x log x minus x.
No, it is not coming like that. Because if you take this
Ma'am, it's coming log of log
if
n.
you take this as z, if you take log of x as z.
Ma'am, it's coming log of log n.
If you take this as x, then derivative of
Yes,
this term you get
yes,
in the
ma'am.
first term. So you can directly take the z value and then integrate. So 1 by z integration is log z. So you will get log of log x.
Yes, ma'am.
Okay. Yeah, whenever you post it, you please post it in a straight form. It is difficult to see the slanted one.
Ma'am, it's coming infinite, so it is divergent series.
Okay, take another example. Test convergence of this series. x square e to the power minus n cube. Summation of n equal to 1 to infinity n square e to the power minus n cube. I'm repeating it again. N square minus n cube.
Ma'am, limit says 1 and infinity.
Yeah, limit is 1 in infinity because it is starting from 1.
Ma'am, it is n square into e to the power minus n cube.
Yes. You take this as z.
Ma'am, it's convergent.
Yes. What is the value of integral?
Yes, ma'am.
1 by 3e.
1 by 3.
Yes, 1 by 3. So it is a finite value. Therefore, it is convergent. Okay, so somebody post the solution. Before applying this theory, you have to first prove that this is what you have to prove. The function is
Finite.
Decreasing.
oh, decreasing. Is this function
Decreasing, yes, ma'am.
How will you prove that this is decreasing?
an plus 1 minus n minus an.
dy by dx.
वो भी कर सकते हो लेकिन मैम ने बताया था कि an plus 1 minus
Your
an.
test.
Yeah, don't use because this is not a calculus chapter. So you don't use the derivative. You use the series concept. Okay. So using the
Yes, ma'am.
series concept, you can prove that it is decreasing. Just directly
Okay, ma'am.
first you prove that it is decreasing, and then you integrate. Okay, now let us come to the alternating series. So I have said what is alternating series. Anybody who remember what is alternating series?
In which alternate terms are negative.
Yeah, alternative terms are negative. So you can have the series like this: u1 minus u2.
Like ln2 series.
Yes, or you can have minus u1 plus u2 minus u3 plus u4 and so on. So this series is called an alternating series. So when we prove the convergence and divergence of alternating series, then we apply a test which is called Leibniz test. So that is why this test is given the name Leibniz test for alternating series. So what is the property of this Leibniz test? The first property is that you have to prove that the given series is monotonically decreasing. Okay. First proof. Okay, this series can be written in general form. Summation of n equal to 1 to infinity minus 1 to the power. If you take it as n minus 1, then that also works, or if you take n the plus 1 also. So this is un. Okay, so when you use this test, you don't consider this sign. You don't consider this sign. You take only un and check whether it is decreasing or increasing. So to prove the series is monotonically decreasing, that the series un is monotonically decreasing. Okay, monotonically decreasing, that is un plus 1 should be less than un. We don't consider this, but we don't take the mod also, because the theory means, in other way you can see that it is a modulus of this, but we don't apply the modulus concept, but we just take that we consider only the positive part of the term. And the other thing is that you prove that limit n tending to infinity un is equal to 0. So these two if we prove, then we can say that alternating series will converge. And alternating series will not diverge, it will oscillate. Okay, when it is converging, that means it is having a unique value. Okay, when it is not getting a unique value, that means it is oscillating. It will either oscillate finitely or it will oscillate infinitely. Now let us take one example. Test the convergence.
Ma'am, can you repeat this once again, the second point?
The second point is limit n tending to infinity, un should be equal to 0.
For converging.
Yeah, these two, both the thing we have to prove. If we just prove one part, it will not prove, because the Leibniz test is connected with these two proofs.
Okay.
Okay, both you have to prove. So you take this series 1 by square root of 2 plus 1 by square root of 3, and so on. Test the convergence of this series. So you can write this in the form.
Ma'am, what you wrote above at the topmost.
The first proof is prove the series un is monotonically decreasing. That is un plus.
No, ma'am, not this, ma'am. The summation n is equals to 1 to infinity minus 1 to power n minus 1 into un.
Into un. Just we are taking this in summation form. Okay. If you want, you can take plus also. That is not an issue. But we have to just make sure that this is alternating.
Ma'am, it is converging.
It's converging.
You take it as plus 1, not an issue, so you can write it as square root of n.
By
Now
root
what
n.
you have to first prove that this is monotonically decreasing. Is this monotonically decreasing?
Yes, ma'am.
So this is monotonically decreasing, so first part is 0, proved. Now when we take the limit,
It's 0.
0.
Tending to 0.
tending to 0. So this test is applicable. Now you take another example. Test the convergence of
And the two conditions were for a converging series.
Yes, both the condition you have to prove. If you miss any one condition, then the proof is not valid.
So will you please move to the previous page, ma'am?
I have deleted.
I'm not.
Then I have to do undo. All these things are there in the book which I have uploaded here. Okay. So no need to worry.
Yes, ma'am, done.
So your problem was test the convergence of this. Here it is given that x is less than 1.
It is converging.
It is converging.
It is converging.
It's converging.
Fourth step, let me see. To take this example, also this is a good example. Test the convergence of this series 1 by 1 to the power p, 1 by 2 to the power t, minus, and so on.
Ma'am, is there any condition on P?
Yeah, you have to choose the condition on your yourself. So you have to choose 3 cases. When P is equal to 0, when P is greater than 0, when P is less than 0. Using this concept, then you can check whether it is increasing in which way and decreasing in which case.
How one can prove that first one is first question in the first question it is a decreasing one?
If we take P is greater than 0. So just in a general way, first you have to prove that it is monotonically decreasing. So what is UN term of the series?
1 by
I'm asking for the first.
1 upon n to the power. 1 by n power p.
Yeah, 1 by n to the power p. Now you find UN plus 1 minus UN. What is the value? From this only you can understand, taking the case of this P, whether it will increase or decrease. Because if P is in the denominator, so if the value of P is larger, so what will happen to the series? If P is in the denominator and P is larger,
It is decreasing.
yeah, it will decrease. If P is negative, less than, if it is small, then what will happen? So just,
It will increase.
Yeah, so it will
Then
just,
UN plus 1 is greater.
yes. So just taking the situation of P, you can check whether when it will increase and when it will decrease. So this will become so what this becomes?
Ma'am, at p equals to 0, is it oscillating between minus 1 and
Okay, let us first take the case greater than 0, 1 by 1. So when it is greater than 0, so what is the value of this term? Is it positive or it is negative when P is positive? When P is positive,
negative 0, less than 0, it is decreasing.
Less than 0.
Are you sure? Are you sure?
Yes.
Check carefully.
Ma'am, it should be np minus n plus 1p in the numerator.
It should be n plus 1. See, un is this. Un plus 1 is 1 by n plus 1 whole to the power p. So when you subtract it, then it is fine. This is okay. There is no problem in this. Yes?
Less than 0.
All of y'all are getting the same thing?
Greater than 0 only, ma'am, but decreasing.
Is this less than 0 or greater than 0? Less than or greater than 0?
Greater than 0.
Less than 1, sorry.
Don't mix, just say it confidently.
Greater than 0, ma'am. Less than 1.
It is less than 0 or greater than 0? Less than 0 it will be. You just check out.
Ma'am, you
Less than 0, ma'am.
ma'am, you wrote the terms in reverse, ma'am.
Yes, ma'am.
P
N to the power p minus n plus
to
p.
the power p.
Yes, there is.
Terms got reversed.
So it is decreasing. Monotonically is decreasing. Now there is one more case left to prove. That means you have to prove that limiting value is 0 for positive value of p. If you are able to prove that, then you can prove that this will converge. Okay, the other case you try at home. What will be the case when p is less than 0 and equal to 0? Then we will discuss in the next class. Okay?
If less than 0, it will be not defined.
Okay, we
This case won't work.
We shall discuss in the next class. Okay?
भाग गई भाई डाउट नहीं पूछने दिया, बताओ।
तो वार्निंग भी नहीं देती है, सीधे चली जाते हैं।
टीम्स भी कॉल कर लो भाई।
अच्छा यार, टाइम पे चले जाती है।
Anyone have the last question solution? Please post.